Hello, everyone. I'm Victor. I'm your host and your speaker today. Thank you all for joining this webinar. We will hear some stuff about color measurement today. And thanks once again, all of you, for joining. So let me start right away. So our topic today will be accurate color measurement on digitally printed materials. I'm your host, the speaker today. My name is Victor. I'm Business Development Manager here at Barbieri Electronic. So, a brief outlook about the agenda today. First, we give a brief introduction about Barbieri Electronic. Then we hear about color in digital printing. Then I will talk about challenges for reflective substrates, challenges for transmissive material. I will talk about how Barbieri automated color measurement solutions help. And at the end, we do a brief summary and then a live Q&A session. So let's get started. Barbieri Electronic stands for Intelligent Color Measurement Technology for Top Performance in Professional Digital Printing. What does Barbieri Electronic do? Barbieri Electronic builds spectrophotometers for color measurement in professional digital printing, and is the color measurement market leader for large format, flatbed, and industrial printing. Let's dive quickly into the history of the company, founded about 30 years ago in Brixen, Italy, in the middle of the Alps, beautiful alpine city. Company started to build densitometers first, and then around the year 2000, the first spectrophotometers and the shift to digital printing. In the year 2004, the first spectral LFP came out. 2010, the spectral LFP Series 3, which is still in production. About 4 or 5 years ago, the spectral LFP QB. And 3 years ago, the spectral LFP QB Textile Edition, our latest cutting-edge technology. Let's dig into color in digital printing. There are different applications in digital printing. There is textile printing, industrial printing, signage printing, sportswear, backlit printing, other applications like printing on ceramics, printing on woods. In fact, digital printing offers a variety of applications, variety of printable materials, and a variety of printable colors. Besides others, this leads to a major challenge: accurate color results throughout different applications. There are reasons that the color results in digital printing varies. We heard about different applications: printer, material, ink combination. Those applications require different production workflow and different pre and post treatments. And all of this leads to a different color gamut or difference of the amount of printable colors. Let's have a look at an example of different gamut sizes in digital textile printing. You see here a variety of gamuts. If we pick 2 of these out, let's choose pigment 4C and reactive 8C, you see that the gamut on the right side is bigger than on the left side. So in this application, more colors are able to be printed. This, of course, does not mean that one application is better than the other. It just shows that there's a difference. And this is not just in textile printing, in other print applications as well. Now, how we can obtain this color gamut graph? We need a material with printed color charts, and we need measurement technology. More precise, we need a spectrophotometer. There are different components involved in color reproduction. It all starts with an image or a digital file. The file is processed by a software, a RIP software using ICC profile, and then sent to a digital printer. The spectrophotometer plays also a major part in this process. Spectrophotometers measures the output of the digital printer and sends the measured spectral data to the software that helps the software then to create a proper and accurate ICC profile. Now let's have a look at the challenges for reflective substrates. And first, let's try to answer this question. What does it mean to measure colors? It all starts with an object. In this example, a green shoe. We need a light source or illumination, and we need an observer, in this case, the human eye. By illuminating the object, a certain light information is reflected back from the surface of the object, and the observer or the human eye is then able to see the color. Now, in this case, this can be defined that the person here says, okay, this object has a certain color. Of course, in digital printing, this is not enough. We need spectral information. Therefore, the color corresponds to the spectral product of these three components: illumination, object, and observer. So Barbieri transfers this theoretical knowledge into technology. In the technology, the same thing happens. We start with an object, a printed chart. We have an illumination or light source built in the spectrophotometer. And we have an observer, a spectral core, who collects the light information and is able then to provide spectral data. One of these key components is the illumination. Barbieri uses the QB technology, a next generation illumination based on LEDs. The QB technology has 3 LED modules inside, and this allows to homogeneously illuminate the media surface, which is very important to have accurate measurement data. There are different characteristics of reflective materials that affect measurement data. Material like paper, banner, vinyl, there's materials with structure like textile, ceramics, stone, and so forth. And all of these materials have different characteristics. There can be optical brightness in the material, there can be glass, ink type, or different behavior of the ink, the surface or the structure, pre and post treatment, and overall the production process. Also, inks have different characteristics and affect measurement data. There's regular ink, and there's fluorescent ink, for example. We see immediately fluorescent inks just behaves differently. There's different amount of light coming back versus when you look at the regular ink. Then there's also wet ink. Sometimes after printing, the ink is not dry yet. Therefore, the surface is more shiny, more glossy. And of course, that's also a challenge for measurement data. Another example would be the difference between UV ink and solvent ink. On the UV ink side, the ink stays on top of the media. versus on the solvent ink, the ink drops into the media. You immediately see that the surface of both materials are different. One is flat and one is not so flat. Let's have a look at an example of a textile material. You see here a printed chart on a textile. One challenge of this particular material is the structure. You see it's not uniform, it's not completely flat. You see different fibers, different lines, and that's a challenge for a measurement device. Next thing is the distortion or the elasticity of this material. Then the mounting itself. Sometimes it's very tricky to place a material on a measurement device, and this can happen with all different materials. And another challenge is the pollution of the measurement device that can happen during measurement process. Fibers or dust can easily go into the optics and have an effect on the measurement data. Now let's have a look at transmissive substrates. Prints on glass, similar transparent, translucent material are special. You see here an example of a glass plate, an example of a bus stop advertising. It's special because the printed image is illuminated from behind. So why do we need transmissive measurements? Because the final application and final illumination of the printed product defines the actual measurement mode. So there might be cases when the backlit material is printed, but still it's viewed at day in a bright environment with illumination from the front. Then, although it's a backlit material, still reflective measurement might do the job. But if you do have backlit material viewed at day under daylight and illuminated at night with backlit, we need transmissive measurements to have accurate results and good color profiles. So measuring transmissive media means that there's a physical light source on the backside of the material. So you see here in this image, there's a calibrated light source at the bottom of the device. The media is in between the light source and the measuring head, and the measuring head above the material to collect the spectral data with the spectral core. One thing to be aware and to pay attention is that with transmissive measurements, always beware of stray light from neighbor patches, which can affect the accuracy of the measurement data. Now, let's have a look how Barbieri automated color measurement solutions help. The spectral LFP-QB combines universality and precision with a broad range of features for color measurement in digital printing. In fact, you see here a fully automated device which is capable to measure a big variety of different materials. And again, everything can be measured fully automated. So this solution can measure textiles as well as glass, backlit, paper, vinyl, silk, fabrics, fine art paper, but also heavy material like wood, stone, ceramic plates, and many more. What are the different applications for these Barbieri measurement devices? Devices can be used for linearization, which means checking the ink drop for each color channel, ICC profiling, which is describing the color space of the digital printer, spot color measurements, so checking the values of spot colors or LAB values, and process control, which equals verifying the stability of a printing process. Let's have a look at few of these core features of the device. First feature is the automation. Color charts can be measured fully automated thanks to a motor inside of the spectral LFP QB. Let's have a quick look how this actually works. The next feature is the variable measurement aperture. The aperture size can be adapted automatically to 2, 6, and 8 millimeters on the spectral LFP QB. This is important because the measurement aperture defines how much of a certain batch is seen and measured. As a general rule, bigger aperture means much more accuracy. To see a few examples on a low resolution print with a small aperture size, you collect only little information about this color batch. So the bigger the aperture, and you see an 8 millimeter aperture on the right side, just provides way more accurate information. Even more so on textiles or structured material. The small aperture, you miss a lot of valuable information. In fact, it can happen when you measure a hole in the material, and this, of course, is providing not good data. With a big aperture, you have way more accurate spectral data. So the best result in textile fabric structure is a large 8 millimeter aperture. To show the difference between 2 and 8, it's not just ×4, but in fact, the 8 millimeter aperture covers a much bigger area. In fact, 17 times larger area. Let's have a look how this works.
What's the real challenge when it comes to color measurement on different digitally printed materials? It is important to avoid wrong measurements caused by a minute measuring aperture. Materials with even surface and high-resolution prints can be measured with a small aperture so that many patches can fit on one single page for easier handling. Structured materials and surfaces require a larger aperture and larger patches to reach the highest level of accuracy. With our professional R&D department, we have been able to look closely at the obstacles and find the best solution. The Spectral LFP QB with its variable 2 to 8 millimeter aperture. By using a motor-driven optical zoom, the aperture size can be adapted automatically. This single instrument can be used to accurately measure a variety of different digitally printed materials to get the most accurate results every day.
Okay, here we have seen how this variable measurement aperture works in the spectral LFP QB. The next feature is vision technology for distorted targets. So you see here a camera, and this integrated vision technology is able to capture the exact measurement spot. In fact, by detecting the center of each batch, it guarantees the highest accuracy. Very important for example, distorted targets. Let's have a look how this feature
Are precise
works.
color measurements on digitally printed textile materials important to you? Placing textiles on a sample holder can be difficult. As a result, the measured charts end up in a distorted position and the device measures in the wrong places. Our experienced R&D department has analyzed the problem and developed the right solution to solve these challenges. Precise navigation can be achieved with integrated vision technology. We have created the sensing unit. It detects patches and provides you with an automated measurement. Measuring distorted charts is no longer a problem because of this intelligent solution based on our vision technology. Thanks to Barbieri technology, precise color measurements make you a top performer.
Next feature is the electrostatic sample holder. This textile sample holder allows easy mounting of printed textile charts. Let's see in this video how this works.
Do you need precise color measurements on digitally printed textile materials? Fixing textile samples on a sample holder can often be very challenging and difficult to implement. Our R&D department has the experience needed to analyze the difficulties and find the ideal solution. Color measurements need to be made on a standardized white backing material. We use the electrostatic charging to pull the desired material on a white surface and, additionally, installed a frame to fix the sample. The Spectral LFP QB textile sample holder. Textile materials get pulled on a standardized white surface by electrostatic charge and are additionally fixed with a frame. This provides a stable measurement position and guarantees precise data outcome. Thanks to Barbieri technology, precise color measurements make you a top performer.
Next feature is the air blowing system. We heard before that dust and fibers can pollute the optics. And with this solution, this built-in solution, Barbieri is able to avoid this behavior and keep the optics clean. Let me show you a video how this works.
Do you need precise color measurements on digitally printed textile materials? Fibers and optics can very often cause imprecise measurements. Our specialized R&D department has many years of experience in the field and has thoroughly analyzed the problems with measurement inaccuracy caused by fibers and dust. Our team was able to solve the difficulties with a high-quality solution. We have created an integrated solution that avoids contamination, the air blowing system. Dust on the measuring aperture gets blown out of the optics. This guarantees a highly accurate data outcome every day. Thanks to Barbieri technology, precise color measurements make you a top performer. Intelligent measuring technology. When color quality counts. Barbieri.
We covered so far a lot of features for reflective material. And now we have a special feature as well for transmissive material, the integrated transmission unit, which is a calibrated light source. And this video explains how this technology works.
What's the secret behind precise color measurement on digitally printed backlight materials? Light boxes are not uniform and use a variety of different lighting technologies. We found that a single point calibrated and stabilized light source needs to be used to illuminate through the material, and the sample to be measured needs to be moved over it. Thanks to our experienced R&D department, we were able to analyze the challenges and find the right solution. The Spectral LFP QB automated spectrophotometer with integrated transmission unit. A fixed and calibrated transmission light source ensures a constant illumination, and the motorized table guarantees automation and high accuracy in positioning at the center of the patches. For you, this means highly accurate data outcome every day. Thanks to Barbieri intelligent color measurement technology, precise color measurements will make you a top performer. When color quality counts, Barbieri.
So before we go into the summary, I want to show you a quick live action about the Spectral LFP QB. So how the device works in action. So first thing, you place your printed target on the electrostatic sample holder or whatever other holder you need for your material. And then you see on the On the right side, our Barbieri measurement gateway software. The device works very well with a variety of softwares out there, RIP softwares, profiling softwares for digital printing market. In that case, it's connected to USB. It also has an Ethernet connection, so you can connect over network. First thing is the device checks the height of the material, and then it checks the coordinates to measure. It's called the auto positioning. So it checks with these lines. Then it drives into the starting position, and then the device starts the scanning process. And again, all the settings like the measurement aperture, illumination, everything can be set up fully automated through a software. All you need to do then is to click start, and everything goes fully automated. So our final chapter, the summary and the Q&A session. So we heard about accurate color measurement in digital printing today. Color varies on different digital printers and applications. Different material causes challenges for measurement devices. And in the end, with a dedicated color measurement device, spectral photometer, you can deal with those challenges and accuracy is guaranteed. Okay, I think that's it. So for all of you who have submitted questions, and maybe we can provide some more detailed information, we will reach out after the webinar. Again, we will, to our registered users, we will send a follow-up with the recording. It was a pleasure to talk to all of you. Thank you for your time. I hope I could give you a little bit more insight. And once again, if you have any questions, just visit our website, get in touch with us. We are happy to help. So I wish you a great rest of your day and hopefully see you all soon. And thank you.